Okay, looking at rational inequalities, I would like to know when x squared plus 4x plus 3 over x squared minus x minus 6 is greater than 0. Now, what's going to make this problem easy is the fact that because we're comparing it to 0, we only need to determine intervals where this is positive. If you can find an interval where this is positive, that's an interval where it's greater than 0. If you can find an interval where it's negative, then that's obviously an interval where it's not greater than 0. Now, what are the key intervals we should be looking for? I'm assuming by the time you're watching this that you've already learned how to graph rational functions. And key features of a rational function are the zeros and the poles. The zeros are the roots of the numerator, and the poles are the roots of the denominator. So I'm going to factor this top and bottom, and we're going to look for our zeros and our poles. So when we go to factor it, that top, we have numbers that add to 4, multiply to 3. That's x plus 3 times, add to 4, multiply to 3 times x plus 1. And that's divided by numbers that add to -1 and multiply to -6. So that would be x minus 4. No. X minus 3 times x plus 2. Sorry, that's a minus 3 there. Okay. And we want to know when that's greater than 0. Well, the key points are the zeros. My zeros are x values that will make the numerator 0, or the roots of the numerator. My zeros are at -3 and -1. My poles, those are the roots of the denominator, and they're at +3 and -2. And the reason why they're of interest is when I go to graph my rational inequality, so the function of this rational function, it might look something like this. And the points of interest are going to be the zeros, where it hits the x-axis, and the asymptotes, and I determine the asymptotes by the poles. Okay, so my intervals are, this thing is defined from -infinity to -3, from -3 to -2, from -2 to -1, and from -1 up to 3, and then from 3 to infinity, giving me 1, 2, 3, 4, 5 separate intervals to consider. And all I want to do is determine with each of these intervals if this whole rational function is either positive or negative. So all I need to do is find a point in each of those intervals, some test point, like a number between -3 and -infinity, it could be -4. Or between -2 and -3, it could be -2.5. I'm going to put a test number in each of those intervals and determine if this whole thing is positive or negative. I don't even have to evaluate the whole thing. I can just find out if the factors are positive or negative. I'll show you. So I'm going to find some number between -infinity and -3. Let's say -4. And if I put in a -4, this thing is going to be negative. -4 plus 3 is -1, so that's negative. This one's going to be negative. This one's going to be negative. And -3 plus 2, this is also going to be negative. So I'm going to have a negative times a negative, which is a positive, divided by a negative times a negative, which is another positive. So this whole thing is going to be positive when I'm between -infinity and -3. I know that it can't make any change between negative infinity and negative 3, because if it could, I'd have to have either a 0 or a pole there. So from negative infinity all the way up, my first 0 or pole is at negative 3. It's where we have a 0. Now, when our function is between negative 3 and negative 2, so let's say negative 2.5, let's see what each of those factors are. This one's going to be a positive. This one's a negative. This one's a negative. And this one's a negative. So I've got a negative on the top. I'll have a positive on the bottom. So this whole thing will be a negative. What that tells me is that this rational function is a negative in the interval from negative 3 to negative 2. Now between minus 2 and minus 1, let's put in minus 1.5. And this is a positive. This is a negative. This is a negative. And this is now a positive. See how just one of these change as we go between each of those intervals? What do we have now? A negative over a negative, so that's a positive. Now let's look at the interval from minus 1 to 3. I'll put in the number 0. It's the easiest one to deal with in that interval. And if we put in a 0 for x, we've got positive, positive, negative, positive, making this whole thing a negative. And finally, as we go from 3 to infinity, so let's put in the number positive 4, we get a positive, 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 positive. The whole thing is positive. So, when is this thing positive? When is it greater than 0? It's greater than 0 here, not here, here, not there, and here. So, it is positive when x is in the interval from negative infinity to negative 3, or in the interval from negative 2 to negative 1, or in the interval from 3 to infinity. If I was to graph that out on a number line, let's make that minus 4, 3, 2, minus 1, 0, 1, 2, 3, 4. From negative 3 to negative infinity, so from negative 3 that way, from negative 2 to negative 1, so negative 2 to negative 1, from 3 to infinity, so from 3 and then onward to infinity. So graphing on a number line, these are the x values where this rational function is greater than 0, or where this rational function is greater than 0. Why are these open and not colored in? That means you don't include the endpoint. I'm not including the endpoints because my endpoints are either my asymptotes coming from the poles, which make this thing undefined, or they're my zeros. And when it's 0, it's not greater than 0 or less than 0. It's equal to 0. That's why those are open. If you want to understand visually what this looks like, I've got the graph here. So here's a plot of it. It is greater than 0 here whenever we're between 3 and infinity. As this states, from 3 to infinity, it's greater than 0. It's also greater than 0 here on this interval from minus 2 to minus 1. And that's what I've got here, from minus 2 to minus 1. It's above the line, it's greater than 0. And it's also greater than 0 from negative infinity to negative 3. So from negative infinity all the way up to negative 3, it's greater than 0. For all other values, this curve is less than 0. That's why we have the gaps in our number line.